Here we are at dispersion page 3. I'm going to work the last two problems of the page. The times taken for 50 students to complete a crossword puzzle are shown in the table below. This is new because instead of just having one number on the left side, it has a range of numbers. M ranges between 15 and 20, 20 to 25, 25 to 30, and so on. Find an approximation for the mean and standard deviation. Well, the reason why they say find an approximation for the mean and standard deviation is because they've put the data in groups of 5, we've already lost some precision here. We don't know anymore about the 3 students that are in the 15 to 20 range. We don't know if they are 16, 17.5, 19.3. We don't know exactly what, we just know that they're between 15 and 30. So if we use this data to find the mean and standard deviation, they have to be estimates because what we have left is not precise. Okay? So what are we going to do? Well, remember what we did with histograms. When we have a range like this, we need to take a representative value for each range because we cannot enter the range 15 to 20 into the calculator. What we need to do is find the middle value. In this case, it would be halfway between 15 and 20, which would be 17.5, 22.5 for the next one, 27.5 for the next one, 32.5 for the next one, and so on, okay? So we need to take these middle points of each range, and we're going to put that in the calculator to represent the range. And then we're going to put this into list 1, we're going to put this into list 2, and then we're going to run one var stats, and we're going to find the mean and the standard deviation of that distribution. And when we do that, we are actually finding an estimate of this data. Okay, so I'm going to enter this data into stat edit. Okay, I'll put it in L3, L4, and then we're going to run stat calc. Okay, so I just entered the data in. Now we're going to do a stat calc with L3 and L4 for one var stats. L3, L4, and we're going to do a calculate, and we're going to check the mean, which is going to be 32, and the standard deviation, which is going to be sigma, 7.57. Okay. All right. Now, the next one is similar to the last one. We do need to put representative values for each range because it does have groups of data here. The percentage marks obtained for an ITGS, Information Technology for a Global Society, test by the 25 boys and 25 girls at Bright Height are shown in the table. Calculate an estimated value for the mean and standard deviation for the girls and the boys separately and comment on your findings. Now, the only thing confusing I thought about this table is that they always put frequency on the right side. And this is like one of the only problems where it's a little confusing because they put the girls' frequency on the left side and the boys' frequency on the right side. But just think of this as maybe like two different tables, right? You got the data, and then you got the boys' frequency. And just think of it as also the data and then the girls' frequency, but on the opposite side. So what we can do is we can enter these 3 columns. We don't have to enter the data twice. We can enter these 3 columns into the calculator. And then we just, when we run stat calc, I'll show you how to do it all separately. So first we're just going to enter all this data into the calculator. And remember that instead of 0 to 10, 10 to 20, we're going to put representative numbers, which is halfway between 0 and 10, for example, is 5. Halfway between 10 and 20 is 15. Halfway between 20 and 30 is 25. And so we're always going to put a number that's halfway in between. So it'll be kind of like this, right? All right? And so we're going to enter that in the I have entered these 3 columns of data into stat edit, and I put the percentage marks on the left side, and then I put the 2 frequency columns on the right of those. Now I did not put a separate percentage mark column for each frequency, and I'm going to show you how to reuse that. So the left column is L1. First I'm going to process L1 with L2, and that would be processing the girls' data. And then I'm going to do L1 and L3, and that would be processing the boys' data. Okay? So first I'm going to do the girls' calculations to find the mean and the standard deviation for the girls. I'm going to put stat calc, 1 bar stats, and I'm going to put L1, and then I'm going to put L2, and then I'm going to calculate, and I'm going to get 55.4 for the girls' mean, and then I'm going to get 11.5 for the standard deviation. And then I'm going to do, that's for the girls. Now I'm going to do the boys. Same thing, except for now I'm going to do stat calc 1 bar stats, and I'm going to put L1, and then for the frequency list I'm going to put the boys data, which is in L3, and then calculate. And now I have that X bar is equal to 51.8, and then I have that the standard deviation is 23.1. Okay, and so now it says comment on your findings. Well, if I compare the mean for the girls and the mean for the boys, I can see that on average the girls have have higher scores. These are scores, right? Percentage marks. But the boys' data is more dispersed, right? Because its standard deviation is 23, and for the boys, and the girls' data is only 11.5. So the boys' data is more widely distributed, and you can kind of see that it ranges from 0 to 100, whereas the girls is more concentrated here in the middle from 30 to 80. Okay, so that's it for page 3.